Together today, we're going to go over a chemistry passage and a cars passage. Any questions so far? All right. If not, we're going to jump right into the passage. If you haven't opened the passage for today, go ahead and use this link, or you can just go to Khan Academy's MCAT passages and search the sensory adaptation or Weber's law under their psychology passages. I'm gonna hold on a minute while you guys get that pulled up, and we'll jump right in. All right. So for this question, it's based on Weber's law or not necessarily on Weber's law, but on the concept, and it is a purely knowledge question. So the main concept we have to understand here is the just noticeable difference. And the just noticeable difference is a threshold or a measurement for detecting change in a stimuli from one level to another, or the difference between two different stimuli. So in this case, if we're looking at a 20-pound weight, that is the original stimulus, and the person that's lifting the weight notices a difference when you add an extra half a pound, the threshold for the weight to pass for them to notice a difference is half a pound. So in this case, the answer would be B. All right. Any questions so far? Perfect. If not, we can move on to the next one. So the second question we have here is about cues or perception. So there are different cues that we use to understand what we see around us, right? And so the cue that we have that's talking about depth here is actually retinal disparity. And retinal disparity is, as I'm sure you've guessed, a visual cue. And it's important in that it uses both our eyes or both our retinas and the gap between them to create slightly different images that give us a perception of depth because of where we focus using our different retinas and the image we get based on that. So to explain the other ones, relative height is a monocular cue, so it's using one eye. And all it's letting our brain understand is that when we see multiple objects, the higher objects are perceived as further. And you can think about that in terms of a painting. When we're looking at things toward the bottom of the painting, they appear closer to us, and things at the top near the horizon or in the sky appear further away. Then we have shape constancy, which is the perception of the object's shape and our brain understanding that as not changing, even if it does visually. So you can look at that in terms of a door closing. So we know that the door is rectangular when it's closed, but when it's open, it doesn't appear directly as a rectangle and as that flat shape that we see when the door is closed. But our brain still understands that it's the same shape. So that's shape constancy. And the final principle is motion parallax, also known as relative motion. This is also a monocular cue, and which means you only need one eye to understand what it's trying to tell you. And all that's telling you is the information on if things are closer or further based on where you're focusing. And that just appears in the way of closer objects moving faster across your field of vision, and farther objects moving slower across your field of vision. So that is the answer to the second question. And let me know if you guys have any questions about that one. And if you'd like to open up the passage now, there is the passage link in the chat. So thank you, Nisha, for that. If not, we can move on to the third question. So yes, retinal disparity is a concept where we're looking at the different images that our two eyes create. And the reason that we have different images is because our eyes aren't in the exact same spot. And so since they're placed slightly apart, we get slightly different views on the object we focus on. And so our brain puts those two images together to take a look at how far something is and its 3D view rather than using the one image that you would get from using a single eye. Does that make more sense? Perfect. All right, so the third question for this passage. So I would say the key thing to understand about the question here is the word judgment. And so we're looking at a principle of uncertainty here. And when we look through the answers, based on the passage, you can tell that Weber's law actually means the ratio of a noticeable difference in a sense and the background level or intensity of that sense. So where that doesn't necessarily deal with the principle of uncertainty. That's just a level or a threshold that you have to cross for a difference to be detected. So we know it's not Weber's law. Then we have Gestalt principles, which are principles of human perception. So not judgment making by any level. So Gestalt principles are talking about how we group things together based on how close they are, or if the object appears like it's connected fully, or if it looks like it's continuing to a certain distance, or if it's symmetric. Those are Gestalt principles. Those are just how our brain perceives things and groups them together. And Bismarck's theory is something that personally I haven't heard of. And as far as I know, it's not something relevant to the MCAT. So that one can be pretty directly knocked off. So what we're left with is actually signal detection theory. And what signal detection theory is it's a balance of decisions that a person can make in situations of uncertainty. So it's looking at the proportions of how often someone decides to make a yes or no decision based on something that they see or hear or they perceive to see or hear. And if we don't have any questions about that, we can move on to the fourth question. All right. So for this question, we can really look at the passage and use the graph and paragraph of the passage. So the key thing here is to understand what an absolute difference threshold and a relative difference threshold is. So the passage talks about Weber's law, which, as the passage explains, is the ratio of the difference to the background intensity of a stimulus. So that is a relative difference because we're looking at how big a change in the stimulus is compared to the original stimulus. So that's relative. And Weber's law is clearly stated in the passage to be a constant ratio. So we know when we look at the answer choices that it can't be a bigger relative difference or a smaller relative difference. So we can knock off both C and D. So we're looking at absolute differences here. And when we take a look at the graph, we see in the graph that based on the level of the original stimulus, the level of the increment or the difference in the stimulus differs. And we see that as we increase the level of the original stimulus, we need to increase the difference of the difference. We need to increase the difference in the stimulus before we detect a difference. So in that case, the level of the original stimulus being either 2 ounces or 5 ounces would have an effect on the difference threshold that we would need to cross to perceive a difference. And since we know that the larger background intensity or the larger weight causes a bigger difference threshold or difference in the weight needed to recognize that there is a change, we know that the 5-ounce weight will have a bigger absolute difference. And as always, feel free to raise your hand or unmute yourself to let us know if you guys have any questions. But if not, we can move on to the next question. All right, so this again is just a knowledge-based concept, and we're just looking at monocular and binocular cues. And what both of those are types of visual cues that our brain uses to understand what we're looking at, right? So monocular cues only use one eye, while binocular cues use both eyes. So the key thing here is to understand that retinal disparity, again, like it appeared in the earlier question, means that we're using both our eyes and we're using the difference in position among both our eyes to create an image for our brain to perceive. And so right off the bat, knowing retinal disparity means both eyes, because you're comparing the eyes, should point this out to you as the answer. But I just want to go through the other ones so you guys understand monocular cues as well. So the concept of interposition means that we understand distance using only one eye by looking at how things are in front of or behind each other in terms of blocking. So if you close one eye and you're looking through just one eye, you're still going to understand that something is in front of another object when it's blocking you from seeing the other object, right? So that's interposition. Relative size is just, again, using one eye to look at how big something is and comparing that to what you'd expect based on its distance to you. So if we see something as larger, we'd perceive it as being closer to us. And finally, we have motion parallax, and that's also known as relative motion. That's where you can focus on one point and you can look at how quickly objects move across your field of vision to assume how close or far they are to you. So closer objects, since they take up more of your visual field, will move quickly across your visual field. On the other hand, farther objects will take up less of your visual field, so it'll take a long time to cross your visual field if they're moving at the same speed. And we can move on to the final question if no one has any questions about that one. So for the final question for this passage, this concept has a lot to do with experimental design. And the first thing we have to understand about this passage is that the researcher did an experimental study where they induced some changes, like changing the weight that was added, and observed the result, which was how often people noticed it or at what level people noticed it. In experimental studies, we generally have the control group, which gives us a baseline of responses, and an experimental group, where we change the amount we add. And without both of these groups, you can't really extrapolate and create findings or analyze findings from the data because we don't know what levels we have normally, and so we can't compare any experimental changes. And the control group in this situation, or in any experimental scenario, gives us a finding or a set condition to generalize any experimental group findings. So if we find that the experimental group differs under only a specific range of weight, that's what the control group is useful for, because it tells us that, okay, they're only different in a specific weight range, and outside these weight ranges, they're still similar. So we can't draw any conclusions about the low end weight group and the high end weight group. So it gives us a baseline to understand that there are changes. And so in the case of the question, we'd have to consider the baseline of activity or the baseline level of detection. And since they don't necessarily test that, we do have to recognize that it is necessary to account for this baseline level. And so they can't draw any real world conclusions until they actually assess this baseline level. But yeah, those are the questions for this passage. If no one has any further comment or question to add about this passage, I think we can move on to the next passage on biochemistry.
Yeah, all right. So I'm dropping the link in the chat. Again, this is one of the pre-assigned passages. It's okay if you didn't get a chance to do it. Just click the link and follow along. And yeah, please don't be shy. Feel free to unmute yourself, type in the chat if you have questions. Interrupt me, stop me anytime. I'm happy to answer questions. Okay, so this passage was over brown adipose tissue, and the first question was asking about figure 2. If some hydrogen ions pass through the UCP, which is the uncoupling protein, what will happen to the production of ATP compared to a mitochondria without the UCP? So for this question, the thought process is fairly straightforward. You kind of have to look at the diagram, see what's happening. And hopefully all of you noticed that hydrogen ions are kind of being siphoned away from the ATPase, and they're going through this uncoupling protein. And so if less hydrogen ions are going through the ATPase, that means it's going to generate less ATP. Does that make sense to everyone? Any questions over that?
Could you just repeat that one more time? I think I
Yeah, of course.
I missed it.
Yeah, sure thing. So for this question, you're looking at the diagram to determine what happens to the production of ATP when there's an uncoupling protein present. And so the uncoupling protein causes the hydrogen ions to flow through a different channel than the ATPase. Normally it's moving only through the ATPase, but this is sort of siphoning those hydrogen ions away. And so what that means that if there's less hydrogen ions going through the ATPase, then the production of ATP is going to decrease because less ATP is being made. Does that make sense? Okay, perfect. Any other questions over that one? Alrighty. So second question, brown adipose tissue has similar features to which other type of tissue? Epithelial cells, neural cells, skin cells, muscle cells. So the answer to this one was muscle cells. And does anybody have an idea as to what part of the passage might have given you a clue or helped you answer this question? It's okay, it's a hard one, but yeah, don't be afraid to make guesses. Safe space. It's like totally fine to guess and get things wrong. But yeah, brown fat has a lot of mitochondria, exactly. So that is the clue here. Muscle cells also have a lot of mitochondria, and the reason for this is because muscle cells have to produce a lot of energy. And so that's kind of the tip off here, I think, just realizing which one of these is different. Because in general, I think the baseline level of energy that's needed for any of these other cells is kind of the same, but muscle cells, sometimes you need like a lot of energy. And so, yeah, a lot of mitochondria, that's sort of your hints that brown adipose tissue also produces a lot of energy. Awesome, any questions about that? If not, we can move on. Question 3, what is most likely the main function of brown adipose tissue? So this question kind of builds off of the previous one. You know that there's a lot of mitochondria within brown fat. And so you kind of have to go through the answer choices and figure out which one sort of matches that function. And so in this situation, the answer is actually A. And this actually requires information also from the graph that's included. So the passage mentions that brown fat is located in the subscapular region and in the area surrounding the aorta. So subscapular region is kind of your biggest giveaway once you look at this graph. And one good hint at reading this graph is sort of dividing it into two. So the bottom here is actually showing oxygen consumption, and the top here is showing the temperature. And so what you see here is the subscapular region is able to maintain a high temperature even at an external temperature of 20 degrees Celsius. And so that tells you that the brown fat, which is pretty prevalent in this area, is probably contributing to that, just based off the information the passage gives. Any questions about this? Or any questions about why the other answer choices might be wrong? All right, in that case, we can keep going. And feel free to message if you have any questions later through Slack or Teams. All right, so which one of the following statements about brown adipose tissue is true? So this one also requires you to sort of draw on knowledge that was gained through the passage and from the previous questions. So the answer to this one is A, that there is an increased number of capillaries surrounding brown adipose tissue. And the reason for that is because you know that there is increased oxygen consumption that relates to the function of brown adipose tissue. And so the reason that you would need increased number of capillaries is so that you have more efficient gas exchange occurring within that tissue. Does that make sense to everyone? Any questions about that? Or again, why the other questions might have been wrong or answer choices might have been wrong? Alrighty. This one is the last question. So how does brown adipose tissue vary with an adult human's BMI? For reference, a BMI above 30 is considered clinically obese, while a BMI less than 25 is considered clinically not obese. So the answer to this one is actually B. Personally, I did not like this question. I thought it was a little confusing, but the reasoning behind this is that, so like it says, higher levels of brown adipose tissue correspond with a lower BMI because every glucose molecule produces fewer ATP molecules for the cell, so the body consumes more glucose. So what it's really saying here is you have to look back again at the function of the uncoupling protein that's present in brown adipose tissue. And you have to keep in mind that because it kind of ties back into like question one, because more hydrogen ions are being siphoned away through the UCP, that means that less ATP is being produced through the ATPase. And so that means that a greater number of glucose molecules have to be consumed to produce an equal amount of energy within that tissue. And one of the byproducts, this kind of ties back into the function of what's it called, of brown adipose tissue, is that one of the byproducts of cellular respiration and oxidative phosphorylation specifically is that heat is produced because energy is lost in the form of heat. And so that kind of ties back to one of the previous questions. But in this regard, at least, you know that a higher level of brown adipose tissue, and level here you would take to mean proportion. So higher proportion of brown adipose tissue corresponds with lower BMI because more glucose in that person is being burned in order to maintain the same amount of energy or the energy required by the cell in that brown adipose tissue cell with the UCP as compared to a cell that does not have a UCP. Does that make sense? I know the logic here can be a little confusing, especially with this concept, and I have seen it come up in a lot of MCAT practice passages before, so please, if you have questions, let me know. Happy to clarify.
I'm just a little confused because I thought that the more glucose you have, the more ATP you're producing. I think I'm thinking of like glycolysis and how when you start with like a lot of glucose, you
Yeah.
produce a lot of ATP. I don't know if I'm even
No, yeah,
understanding.
you're totally right. You're totally right. Yeah. So generally, when you have more glucose, more ATP is being produced. In this scenario, that it gives you with the uncoupling protein. Let me go back to that first figure. So in this scenario, because you have an uncoupling protein here, you are producing less ATP per glucose molecule. So normally, if you're producing like 32 ATP per one glucose molecule, pretend that's cut in half and you're making 16 ATP per one glucose molecule. So instead of burning, I don't know, maybe your cell needs like 106. Instead of burning three glucose to get 106 ATP, you have to burn 6 glucose to get 106 ATP. So that's kind of the fundamental concept underlying this passage. And that's what's going to help you answer all of the following questions, and sort of leads into the logic of that last question where it's asking about BMI. Make sense? Okay, great. Anyone else have more questions or want me to explain that again? Or any of the other questions specifically? It says BMI varies. Yeah. So let's see. Yeah, so can you explain the logic? When you say BMI varies, so okay, so how does brown adipose tissue vary within adult humans BMI? It's asking just like generally, because they're not going to give away the answer of whether there's a positive correlation or negative correlation. So you have to figure that out and then pick the answer choice that fits. And so when it says vary in this situation, it just means that higher levels of brown adipose tissue go with lower BMI. And again, it kind of ties back to a person who has higher levels of brown adipose tissue means that they have more cells with that uncoupling protein. So they're going to need to burn more glucose to burn the same amount of energy. Like again, instead of 3 glucose for 106 ATP, they need 6 glucose for 106 ATP. So they're going to burn through a lot more glucose, and because they're burning through more glucose, they're going to have a lower BMI theoretically, is what this thing is saying. Again, I didn't love this question. I thought it was a lot of things have to be very ideal for this to be occurring. So I feel like the body's more complicated than that. But yeah, so how do you know from the passage? Good question. So this is again one of those things where you kind of have to look at the figure to really understand what's going on. So I personally figured that out just again reading the passage and figuring out what is the function of the UCP and tying that back into the larger knowledge of the body and how that works. So that's kind of the thing about MCAT is like you're kind of synthesizing all of the things that you've been studying, because sometimes with biochem especially, you're going to need to draw on knowledge that you have about the subject as a whole in order to be able to apply it to bigger, broader questions like that last one we looked at. So just knowing that people, like, I guess knowing how like calories and glucose work, like I know it seems something kind of out there, but it kind of wants you to have to tie in all of that logic together. So it's just something that takes practice and in regular studying, which I know you're all doing. So yeah, you're right. The passage doesn't like explicitly say anything about BMI, which is again why, or about that relationship, which is why I didn't love this question. But that kind of is one of those things that you're going to need to be able to draw on other knowledge and background studying from. Does that make sense? If you have more questions about it, you can feel free to message through Slack or Teams. I'm happy to walk through the passage again or any of the questions. But for now, just for the sake of time, we're going to move on to the in-class passages or in-call passages. So we're going to start off with this chemistry passage. I'm going to drop a link in the chat. And we're going to give you all about 8 to 10 minutes to go through this. Just treat it like you would a normal practice passage, and then we're going to regroup. Oh yes, Nikhil already dropped it too, perfect. So yeah, just take 8 to 10 minutes. We'll check in about 8 to see where everyone's at, and then we're going to go through and debrief as a group. Sound good? I'm going to take it as a yes. All right, awesome, thank you. Yeah, 8 minutes.
All right, guys, how are we feeling on time? Is everyone done now, or do we need the 2 minutes?
Feel free to just like drop an asterisk in the chat. Okay, perfect. Drop an asterisk in the chat when you're finished and we'll just like keep track.
All right, guys, and it's been about 10 minutes, so let's go ahead and get started with reviewing the passage. All right. So when we're looking at the first question, it asks us what enthalpy we're looking at when we see the 45-minute mark in the ADP trial graph over here. Would anyone like to take a shot at answering this one? Feel free to unmute yourself or type it in the chat.
I just have a poll actually. If that's easier for everyone, go ahead and just click on the answer choice that you think is correct. And again, just take a guess. Don't be afraid. And if you haven't finished the passage either, it's okay to just vote for the ones that you have or take a guess.
Okay, so we see enthalpy of dilution in the chat, Stephanie. Would you like to explain your reasoning, or do you want me to go ahead and try to explain it? Gotcha, no worries. All right, so for this question, I think the key points we need to understand or look at is the saturation part that they mention in the question, that they're putting in injections of, in this case, ADP for this graph at around every 5 minutes is what it looks like. And over time, this ADP saturates the HSP70 protein we're looking at, and that's super important. And they're also asking us to look at the after 45 minutes, which is a specific part of the graph where we see a very high level of affinity and or binding, and we see a very minimal level of energy change. So we need to understand what each of these answers actually means to answer the question. And the thing we need to look at is heat of vaporization. That is a change in energy that we get from a change in the state of matter. And since we're not looking at any changes or measuring any changes in the states of matter, we know that this can't be the enthalpy that we're measuring. In addition, we're also not looking at heat of hydration because hydration enthalpy, or the heat of hydration, is just the energy change that we get from gases or ions dissolving in water. And we're not dissolving ions in water, we're looking at the affinity between ADP and a protein. So we know it's not heat of hydration either. So now we have to choose between enthalpy of dilution and binding energy. Now, binding energy is the initial change in energy when the substrate and the reactant bind. And that's what we see in this energy release, creating this huge spike over here. That is the initial energy released or gained, depending on the reaction, from the binding of the substrate and the reactant. And since we're looking at the after 45-minute mark, we know that this can't be referring to the binding energy because the binding energy is over here well before 45 minutes, since we see the affinity change and we see the energy create a large spike. So we know it's not that one. So we know it's enthalpy of dilution, but what is enthalpy of dilution? Enthalpy of dilution is just the change in energy or heat energy that comes with dissolving some solvent or some, in this case, ADP into a solution at a distinct and constant pressure. And so as we're continuing to add the substrate ADP and the solution gets more and more diluted, that's when we see this flattening at around 45 minutes, which represents the heat energy change that we get from just diluting the solution further and further and adding this ADP. So in this case, the answer would be D. Are there any questions about this one? If not, I will move on to the next one. So I'll give you guys about a minute or two to answer this one, and then we'll try to review it together. So if you have an idea of what the answer is, or you have a guess that you'd like to reason out, feel free to unmute yourself or type it in the chat. All right. So for this one, it's a pretty straightforward calculation problem given the equation that we get here. And honestly, the explanation and the units that we get here as well. So the first step for this question is understanding that we see the delta G and the KD in the equation above, and they're giving us the units to plug in to just calculate the delta G. So the first step in this case is understanding that we're looking at 100-fold increase in the affinity constant. So when we go back up here, we're going to see this number increase by 100 or get multiplied by 100. And thankfully, they've given us the conversion from natural log to log base 10. So we see from ln of 100, which in this case is KD, we would get 2.303 times log of 100, which is 2. So we'd get 2 times 2.303 for this portion of the equation. Then we just have to use the RT. And for RT, we're given R, which is 1.98, and we have to understand how to get T, which when we look at absolute temperature, that temperature is measured in Kelvin. And Kelvin is Celsius plus 273. So when we find the temperature for this experiment, we just plug it in, and we are given the 1.98 for R. We get 310 K, and we also get the 2.303 times 2, which is from log of 100. So since we don't get calculators on the MCAT, it's just a simple approximation of most of those values. So we can round this to about 2. And then the 2 times 310 is 620. And then 620 times 2 again is 1,240. And then we multiply that by about 2 as well. So we get around 2,700, 2,800. But the key thing we have to understand here is the free binding energy is going to change into a negative value. It's going to be more negative if we're increasing the affinity, because affinity increases when you're releasing more energy. That's what makes reactions more spontaneous, and more spontaneous reactions will have a negative delta G value. So that's where we have to understand that the answer choice is going to be negative. So we will go with D. Does that make sense to everyone?
I was kind of confused on how, in general, how to do this passage because there was a lot of stuff. So
Gotcha.
So what would be your recommendation? Because like this is the section, I mean, I struggle with the most over than the other sections because there's just a lot of stuff.
I 100% understand, and I was there too. I think the main thing is to get used to reading scientific literature. I remember when I first looked at this passage that it took me a while to understand exactly what each graph meant, and I had to use a lot of context clues. I think a better understanding of passages like this comes with looking through more and more scientific literature and really understanding how they set these experiments up and how they set these graphs up. And that'll help you get a better innate understanding of how to read them and read them quickly. Does that help
Yeah.
a little?
Yeah, thank you.
Yeah, no worries. And also, I guess one more thing is to understand that usually when they give you an equation, it's going to be used in the questions, and it's just a matter of finding exactly how to use that equation by looking in the question. I know we have to memorize a lot of things for the MCAT, but they end up giving a lot of equations out, which is nice. But I would also say don't rely on it. Just make sure you know what to look for when they give you the equation. But if there are no more questions about this particular problem, then we can move on. Yes, KD being, we're looking at 1 over KD when we look at the affinity. We're usually looking at KD, you're thinking about means the dissociation constant, which is where it's lower means higher affinity. But in this case, it is the affinity constant. So it's a direct measure of how well they bind, if that makes more sense. Yep. All right. So for the next question, and I just want to let you guys know this is a relatively common type of question that they'll give you in terms of, it's just a concept that I would say you should memorize. Does anyone have any idea about which one it would be? Would you like to try to reason out your, I guess, selection of C as the answer, Stephanie?
It was just something that I remembered from like Gen Chem, that it needs to be a 1 molar concentration of all the solutions. And I think it's 298 K, and 1 mole of each reaction doesn't really make sense. And then having all the elements in their gaseous state doesn't really make sense either. So that's how I got to that answer.
I would say that's a great way to have gotten to that answer, and you are 100% correct. So it would be a 1 molar concentration of all solutes for standard state. But I do want to let you guys know that there are several different standard measurements that are used. And if you look at this section, it does tell you. So we have STP, which is used for gas laws. And that's just looking at the temperature we have as 273 K and the 1 atmosphere as pressure that we use for the calculation of any gas moles or any gas temperature or pressure. We also have standard state calculations, which are generally used for biology, where we have the 298 K or 25 Celsius, and we have the 1 molar concentration of any solute or solution. There's also one more that they don't list on here, which is the standard state for biochemistry. It's actually not 1 molar concentration, and that's because in biochemistry, we're looking at the chemistry of things like acid in your stomach. And if you have an acid like hydrochloric acid at a concentration of 1 molar, it is pretty deadly. So I would say understand or remember that STP is relevant for gases and gas laws, and standard state means the 1 atmosphere of pressure, the 298 K, and the 1 molar concentration. But the 1 molar concentration doesn't apply if you're looking at a biochemical experiment or reaction, just because you won't find 1 molar concentrations in real life in our bodies. But outside of that, again, as always, feel free to unmute yourself or type in the chat if you guys have any questions, but I'm going to move on for the sake of time. All right, so does anyone have any idea about this question? So for this question, what is really important is understanding the adiabatic part. Sorry if I said that wrong, but the adiabatic part means that we have to look at the equation for conservation of energy. And when you look at thermodynamics, we have the balance of the change in energy is equivalent to the change in heat and the change in work. So an adiabatic system means that there is no change in the heat energy of the system. So any change in the internal energy of the system is equivalent to the work, either done by the system or done on the system. So in this case, we know that with an adiabatic shield, we're going to have a balance so that the change in energy is equivalent to the change in work. And since they're on opposite sides, when the energy increases, it is equivalent to the work done on the system, which is also known as the negative of the work done by the system. So that's an important distinction, that the work done on the system is the opposite of the work done by the system. So I can see why I would be tempted to go for A, and that's because that's a different type of system where the process is isochoric, and that means that the internal energy is equivalent to the heat change in the system. So we just have to understand that adiabatic means that change in energy is equivalent to the change in work, and isochoric means that change in energy is equivalent to the change in heat. So in this case, the answer would be D. All right. So for the penultimate question, we are looking at binding affinity. Does anyone have any sort of answer or guess that they would like to make on this question? All right. If not, so the key thing we have to look at is understanding that delta G is a measure of the binding affinity and we're looking for a high binding affinity. So when we look back at the passage, a really important section that I found that is relevant to binding affinity and delta G is, where is this paragraph? So we see here that they give us this equation that delta G equals delta H minus T delta S. I'm sure if you've looked at thermodynamics, you've definitely seen this equation. But in the case of this passage, they use it to reference the changes in different types of bonding and interactions, like the delta H term, measuring the change in hydrogen or van der Waals bonding, and the negative T delta S term is the change in hydrophobic interaction and conformational change. So we know that a negative delta G indicates a good bonding affinity because the more spontaneous a reaction is, which is indicated by a negative delta G, the better the affinity is. So we're looking at a balance of delta H and negative T delta S that gives us the most negative G possible. So we want a negative delta H. So we have here that delta H is represented by the changes in hydrogen bonding. And so if we want a negative term here, we want as minimal change in the hydrogen bonding as possible. So we would want to have good hydrogen bonding because that means there will be minimal change in the bonding since the bonds are so strong. On the other hand, we're looking at as positive a value of delta S that we can get because we have this negative sign in front that is influenced by the temperature. So the greater delta S is, the more negative this entire term is. So if we want a large delta S, we want a large number of changes in hydrophobic interactions. So we are looking at good hydrogen bonding and good hydrophobic interactions, because that means we'll have minimal change here and hydrophobic interactions going together will create a large delta S, which means a negative delta G. So in this case, it would be D. Does that make sense? I will take that as a yes. And if there are no questions, I'm going to move on to the final question for this passage. So for this question, I think what's really important is understanding we're looking at figure 2, and based on these answer choices, we have to look at a lot of different components of figure 2. So for this, we can go step by step. So if we know that KD is positive and that delta G and delta H are negative, it means that it doesn't mean that the change in entropy has to be negative, because delta G equals delta H minus T delta S. So if both of these are negative, then this part here can be either negative or positive, depending on how large the delta H is and how large the delta S is. So we know the change in entropy doesn't have to be negative. All right, so for the next one, we're looking at the dissociation constant, KD, as being greater for ATP and because of the slope of the sigmoid curve. So we know in this case that they are having, it does have a higher slope, but you also have to look at this part of the graph, which shows us that the slope is represented by 1 over KD. So a larger slope means a lower KD value. And since ADP has a larger slope, then that means the dissociation constant is actually smaller for ADP. So we know this one is false. Now we have here that ADP has the highest affinity, while PES does not bind in any specific way. And we can see that represented in the slopes of each curve. So we have the binding curve here, and generally a strong sigmoid curve, one that is very steeply sloped, indicates that we have high affinity. So in this case, the affinity is higher here than it is for either of the others. And PES does not have any strong binding curve. And so we can say that both parts of this one are true. And for the last one, we are looking at how endothermic both of these reactions are. And we see that both reactions are actually exothermic because we see a negative value for the use of energy in the reaction. So both release energy. So in this case, D would be false as well. So then we have C. Does anyone have any questions about any of what's in this passage?
Yeah, I have one question. What threw me off from not picking C was the second part. It says, "While PES does not bind in any specific way to
Gotcha. Okay.
So I thought it was like wasn't showing a like relationship at all.
Mm-hmm.
Finding.
So the key part to look at that is the top graph. When we see these massive drops or changes in energy, that's the binding energy that we see for both ADP and this Ver protein. We don't see that for PES at all. So that's a good indicator that PES does not bind to HSP70. And in addition, we can also look at the sigmoid affinity of like the release in energy. And we see that both ADP and the Ver protein have such a curve, while PES is, honestly, it's like eh. Does that make a little bit more sense?
I think I looked at the wrong one when I.
Gotcha.
But yeah, it makes sense. Thank you.
Yeah, no worries. It happens. But yeah, in that case, I will hand it off to Nisha for the final passage of this session.
Thanks, sounds good. All right, so I just dropped a link in the chat to our last passage, which is going to be a cars passage. So if you guys want to go ahead and click that. I'll give you about like 8 minutes just to go through it. Do your best to do it within the time limit, but it's okay if you don't finish. And then we'll debrief as a group. All right, let's take about 1 more minute and then we can go do it together. So you can just wrap up your last couple questions. All right, is everybody good? All right, we're gonna start off with the first question. So, question 1 is asking, in quoting mainstream critics who call the plots of Italian horror movies weak, the author means that these critics what? So, if you can type in the chat, whichever answer choice you put down, and don't worry, I'm not going to cold call or anything. I just want to kind of gauge where everyone's at. If you're willing to explain your answer, great. Feel free to put an asterisk or something next to your answer choice so that I know I can call on you if you'd like to share. But at the very least, just type in what answer you put down for question 1. All right, well, I see at least one response. Thanks, Stephanie, for being willing to share. Do you want to tell us why you chose B?
Yeah, I'll tell you why. So if you scroll down to the last paragraph, if you can, it says when mainstream critics complain about weak narratives in Italian horror, they're missing the point. So in my mind, the whole point when I was reading it was they were like, the narrative is really like referring to like plot or the point of the story, and they kind of use like Italians. I guess they kind of use the little bit. It's like opposite of how Americans are movies are. It's like narrative and then spectacle for Italians. So that's how I got to confuse the focus on spectacle with poorly crafted plot.
Yeah, that's great. Awesome. Thank you for sharing. Yeah. So that's a great way to look at it. I think I agree that this is definitely a sentence that is sort of highlighting what one of the author's main points are. And just, yeah, if your highlighting doesn't look like mine, don't worry about it. This is just how I highlighted the passage. But as long as you have the main points, you're fine. So, yeah, great job. And so, yeah, for this question, as far as the other answer choices, you can kind of rule out A because this is not really something that's talked about, what the critics' other opinions are. And it's also just a very general type of thing to say. So that's pretty safely eliminated. C, that they think spectacles are not artistic. Again, the critics' viewpoints towards this were not really talked about. And then D, applying the standards of the spaghetti western, which is mentioned here, to horror movies. It is mentioned, but I feel like this answer choice is sort of taking it too far, saying that they're applying those standards here. Instead, this comparison was just sort of to support the point that was mentioned above. So yeah, great. Any questions or other thoughts about this question before we move on? Okay. Question 2. The author claims that most kinds of movies feature breaks in their narratives. The support offered for this conclusion is what? So this is asking you about specifically like the evidence or like the strategy, rhetorical strategy used in the passage. So again, in the chat, if you can drop what answer choice you put down or what your best guess is, and then some sort of asterisk or symbol if you're willing to speak on it. Hopefully different people, if everyone can get engaged a little bit, but no pressure. Okay, well, I'm not seeing anything in the chat, but we can walk through this question together. If anyone doesn't have access to the passage, can you just let us know? Like, you can raise your hand, unmute yourself, chat, whatever works. But yeah, the link should be there. So, all right, so question 2. Looking at this part where about breaks in narrative. So I remember that being around these passages. So passage 3, 4, 5. And there's like a bunch of examples listed. But even just looking at paragraph like 2, where it says here, nearly all film genres have similar spectacles that are breaks from the narrative. And then, for example, so now it's going to start listing examples in a musical, et cetera, et cetera, et cetera. And so basically, you just see like that they do list examples. So that kind of leads you towards strong. And then in between C and D, so strong because the support offers a theory regarding why narratives need breaks, or strong because a list of movie genres and their types of breaks is given. So in this case, it's D, just identifying what type of evidence is being used. Does this question make sense? Any questions about it? No as in it doesn't make sense, or no as in it no questions? No questions. All right. All right. All right. If nobody else has questions either, we can move on. And again, feel free to Slack or Teams if there's any questions later on that you might have. All right, question 3. According to the author, the high quality of spectacle scenes in Italian horror movies are in large part the result of. Anybody want to type in the chat, or just everyone if you can, what you put down for this question? Okay, we have 1A. Anyone pick any other answer choices, or also A? All right. So according to the author, again, the high quality of spectacle scenes in Italian horror movies are in large part the result of what? So A, as was mentioned in the chat, result of how they prioritize their spectacles. That is indeed the correct answer. And the reason for this is if you go through the passage, you'll notice that the author, well, I guess to go to the other question types too, but basically, the author is saying that the point of Italian horror is spectacle, not narrative, right? And so that's sort of emphasized on multiple parts, I think, in that paragraph, and then also towards the end. And so that kind of gives you a hint that, okay, spectacle over narrative, but how do you rule out the other answer choices? So for B, how often they break from the narratives, that one is less of a good answer choice because the high quality of spectacle isn't necessarily related to the narrative breaks. It's just mentioning that that's a quality of Italian horror film is narrative breaks in order to make way for spectacle, which actually would support A little bit more. For C, extreme nature of the plots. Again, the high quality of spectacle scenes, while they are described in pretty graphic detail, it doesn't really say that the extreme nature of any of the scenes are specifically related to why they're high quality. And then moreover, it also mentions that the narrative is halted during those spectacle scenes. So that kind of is incongruent with what the passage is saying. And then for T, the audience expectations for horror films. Again, the audience expectations, I mean, the passage kind of talks about how it doesn't really talk about audience expectations at all. So that's something that you can also cross out just by knowing that that's not something that the author mentioned. So A is the correct answer here. Does that make sense to everyone? If you have any questions, feel free to type in the chat or unmute yourself. Alrighty. Question 4. Italian horror movies mentioned in the passage are notable primarily because they what? So yeah, again, if you want to type in the chat what your answer choices might have been, or what your responses might have been. And again, don't feel pressured to get it right. If you just want to take an educated guess, that's fine. All right, so we have one taker for B, so that's great. So let's go through it. So for A, the passage, the horror movies mentioned are notable because they introduced the art of the set piece to genre films. So going back to where they talked about set pieces, you'll notice that the horror movies mentioned, they do discuss the set pieces, but they never ever said that they introduced the concept of a set piece. So you can cross that one out just because that's one of those close reading detail questions. B, inverting the typical relationship between spectacle and narrative. So this one actually does have some evidence for it because, again, it's mentioned that these it talks about set pieces, how they're elaborately choreographed sequences that usually take place in one location, and then the point of Italian horror, like basically how it's a main characteristic of it. And then the point of Italian horror, again, is not narrative but spectacle. So this actually does have a lot of support from the passage. But looking at the other ones, C, the horror movies mentioned do not differentiate between plot and spectacle. That's not quite what the passage is saying. There are both included, but it doesn't quite say that they're not differentiating between plot and spectacle, because the spectacle is something that is sort of its own characteristic of the Italian horror film. So we can cross that one out as well, just because, again, passage support. And then D, contain no story at all. Again, this is taking sort of the extreme route of, they tend to favor spectacle over plot, but that doesn't mean they have no plot or no story at all. So cross out D. So yeah, B is the correct answer here. Assuming plot equals narrative. Yeah, plot and narrative can be pretty interchangeable in this situation. So paragraph 3 states horror equals spectacle, not narrative. And the last paragraph says narrative equals spectacle. Oh, okay, I see. Let me see. So this last paragraph is actually saying here that, narrative is merely a pretext for spectacle. So yeah, I mean, definitely one of those things where they'll use the same keywords or buzzwords over and over, and sometimes you just have to like make sure that you're catching what they're saying more easily. One technique that I use, or one strategy that I use, is sort of summarizing each paragraph as I go into one sentence or like a few words. That's one of the CAR strategies that we also encourage y'all to use if it's helpful. So yeah, just one of those things is like close read the first time you're going, but then afterwards when you go back to it, you'll kind of remember what they were saying. So it helps to limit confusion, because these CARS passages can be really dense. But yeah, all right. Any other questions? It's not spectacle, but how is inverting? Okay, how is inverting correct? Yeah. So the horror movies mentioned in the passage, so that's like paragraphs, I think 4 and 5. And so how are they inverting? Basically, it's saying how the narrative, so I highlighted this part, the narrative halts for nearly 4 minutes, and then it goes on to describe like this whole set piece and like all of these different spectacle scenes. Same sort of thing here. And so usually when people are watching, they're expecting a plot, but in this situation, again, the narrative stands still and gives way to spectacle. So the typical relationship that is sort of outlined above is like the idea that that there's a narrative that's more important. But in this, like, because here it says like, the narrative is usually halted by spectacle, but in this situation, it's almost describing it as though like those halts for spectacle, like the spectacle is the real focus of the film, just the way that the author describes it. So that's why B tends to have a lot more. I think they were equal, not inverting. Yeah. Let's see. So for the passage, so when you say equal, not inverting, do you mean like you think that that's the way that the passage is stating it, or I don't know if you can just explain a little bit more. Narrative's not equal to spectacle, right? So let me think. Oh, okay, I see. Yeah, so in this situation, I think so. Reading the passage, you're right. The narrative does not equal the spectacle. They're different things, but they are different things. But it's sort of talking about the relationship in the passage. So that's one of those things that, again, like with reading the passage, getting that main idea from each paragraph and sort of building up the main point of the passage, that's something that is helpful in terms of knowing how to answer this type of question, because it's asking about like how evidence ties into the passage's main purpose. So you're not incorrect with your main idea, but remembering what the purpose of the passage is and sort of what this evidence is trying to convey, I think, is helpful in terms of answering. Does that kind of make sense? Where does it say inverting? Oh, yeah. So it doesn't say inverting directly in the passage, but again, I mean, in the passage, it doesn't have to say anything. It's sort of about like inferring what's going on, and cards is a lot of applying your own again, reasoning skills to the passage and to answering these questions. So the passage isn't going to tell you off the bat like what is happening here. So it doesn't say that that it's inverting whatever relationship exists, or that it's not going to tell you outright that the focus is usually on narrative, but that's kind of the I guess the vibe that you get as you read from the beginning, especially from this first paragraph. Like, it sort of lays out the common way of looking at this situation, like on film comedy, and then it goes on to talk about specifically how Italian horror movies are different. And it talks about because spectacle is given more of a focus. So sort of like I mentioned, that one strategy of summarizing each paragraph is helpful, because that way you know, okay, the first paragraph, they laid out the land, like this is what film comedy is usually like. And then as you go on, you'll kind of build the idea of the passage, which is that film comedy is usually this way, but Italian horror is usually this way. So yeah, does that help clarify? If not, that's okay. Please feel free to message me. Yeah, sure. Yeah, if anything is still unclear about that, just feel free to message me if there's anything more specific that you have. But yeah, for the sake of time, let's move on to the last question. Question 5. The author's arguments about film imply that he would be likely to oppose which of the following. So this is one of those questions where you have to really understand what is the author arguing, what is the main point of the passage, and then like highlight like where the opinions are coming through so that you can answer this. So again, one more time in the chat, if you can drop what your thoughts were, which one you would pick if this was the actual MCAT. It's okay if you didn't even get to this question. I know sometimes the passages take longer than 8 minutes, but just like, throw an idea in the chat and I won't call on you unless you want to be called on. All right, we have D. All right, so let's see, going through in order, starting with A. So the author would the author oppose improving the plots of Italian horror film? That's how I pose the question to myself, is would the author oppose XYZ? So would the author oppose improving the plots? In this situation, I think it's a no, and the reason for that being, yes, the author talks about how spectacle is the focus of Italian horror film, but nowhere do they actually say that the plots the plots have to be bad. That's not mentioned anywhere. That's kind of taking it to another extreme. So again, it's one of those questions where you're having to pay attention to, is this actually supported by the author, or is this something sort of, there's a hint towards it in the passage, but maybe the question or the answer choice is like too far to one end. So yeah, that's why you can rule out A, because it's a little bit too extreme. B, would the author oppose films that emulate Italian horror movies? Again, I think no, and the reason for this is because nowhere does the author really say that or mention what they think next level film should be like. So again, one of those answer choices that you can just cross out. For C, would the author oppose less violent moments of spectacle in Italian horror movies? So looking at the sort of examples of spectacle, a lot of these are pretty violent or graphic, and would the author oppose them? So, or oppose having less violent ones? So nowhere does the author actually say that they feel like the violence is characteristic of spectacle. They just describe that this is what a lot of good examples are. So this is not per se one of their opinions, and so we can also cross out C. And then D, would the author oppose an Italian horror film devoid of set pieces? This one makes the most sense. And again, the reason for this is because the set piece is one of those characteristic aspects of a spectacle. And the author takes so much time to describe what some different set pieces look like to the reader. And so you can infer that the author considers the set piece to be really important to Italian horror film. So yes, D is the correct answer. Any questions over that or the rest of the passage? No, all right. If not, that is the end of our practice session. Thank you everyone for coming. Just a reminder, like I didn't share the slides real quick. Well, our email is info@premedpeers.org if you have any questions or feedback or follow-up. And we also have a Ko-Fi link. I have to share it real quickly. Yeah, that's it. So yeah, that's all there is to it. Thanks for coming. We hope this was helpful, and have a good Sunday, everyone.